In this video, we discuss the step response for RL circuit. As we see this circuit, at time equals 0, the switch closed. So this circuit, after t greater than 0, there is an independent source Vs applied to the circuit now. And this circuit, this notion is equivalent for this circuit, where Vs plus this switch can be expressed by Vs multiplied by the step function u of t. Let's review the step response for RC circuit. Let's look at this circuit. At t equals 0, the switch closed. So at t greater than 0, after t equals 0, the voltage source is applied to the circuit. And this notion Vs plus the action of switch is equals to Vs multiplied by u of t. U of t is the step response. We know the voltage at the capacitor can be decomposed as two portions. One portion is the transit response. The other portion is a steady state response, which is this portion here. V infinity, that's the steady response. This portion is the transit response. The step response for RL circuit also consists of two portions. One portion is steady response, the other one is the transit portion. In RL circuit, we discuss the current flow through the inductor. In RC circuit, we discuss the voltage along the capacitor. So when this switch closed long time, when time goes to infinity, this is a DC now. Vs is a DC voltage source, so this inductor is counted as a short circuit. So the current as time goes to infinity, that's the steady response of the current flow through the inductor. That equals to Vs divided by R. That's this portion here. The transit response must have this response A e to the power minus t divided by tau, and tau equals to L divided by R. And A, this constant A, is determined by the initial current. This is I of t equals to 0. That's the current at time equals to 0. So we plug in this initial value and set t equals to 0. So t equals to 0, t equals to 0. Then I should equals to I naught. So we can figure out A, the constant A. A is equals to this I naught minus Vs divided by R. Therefore, the step response for RL circuit is the steady response Vs divided by R and plus this transit response. And in the general form is I of t equals to I infinity, that's a steady response, plus this portion, and this portion is the transit response of the RL circuit.